Hello class, welcome to topic 2. We're going to work on proofs. We're going to take all this information we've established with angles and sides and congruency, and we're going to prove that things are congruent or equal or so on and so forth. So what does it mean to prove something? I'm not going to read this whole little thing, you can read it yourself, but what we're trying to do is to justify or explain what we're doing. Okay, we just can't do things without proof. We have to have a logical reason why we're doing it. So a proof is just linking steps together, uh, trying to show what we're trying to prove. So writing a proof is all about logic. Each step, well, each new step must come from something previously known. Or given to us. We have to have, just can't come out of the thin air. It's got to be something that we either know, that's been logical deduction, or something that's been given us. So each step must be logical. And I'm going to write this down. We're going to do baby steps. So every time we do a new step, it's a small deduction. It's not a big leap of faith. It's like, oh, this makes sense because I just did this a little bit earlier. So like I said, baby steps. So let's talk about things that we should already know from what we learned. We know vertical angles are congruent. In this case, angle 1 and angle 2. We know a linear pair add up to 180 degrees. We know that we have parallel lines cut by a transversal, and we set up this picture with all these angles, that corresponding angles are congruent, alternate interior angles are congruent. Oh, I made a mistake here. Let's see, alternate exterior angles are congruent. And when we have same side interior angles, they add up to 180 degrees. And then when we hear the word perpendicular, that means things are at a right angle, and all right angles are congruent. We don't have to prove anything with it. If I have two right angles, they are congruent to each other. So here we go. This is our first proof. We set up usually a two-column system where the left side is a statement that we're going to say, and the right side is a reason why we can make that statement. So the idea with the proof over here is that I want to start with whatever is given to me, and I want to end what I'm trying to prove. So for this example, I have two things that are given to me. One, triangle ABC, which is this big triangle ABC, is an isosceles triangle. That means something. And AD, line down the middle, is the median from the vertex to the midpoint. Again, these are important ideas. And then we're trying to prove that the triangle in the right half is congruent to the triangle in the left half. Okay, so let's go through what we can do. I always start with the given. Triangle PAC is isosceles. What's the reason? Given. AD is a median. Again, given. Now, because a triangle BAC is an isosceles, I know that this side is congruent to this side. Or side AB is congruent to side AC. Basically, definition of isosceles triangle, or because triangle BAC is isosceles. That's what it means to be an isosceles triangle. Two sides are congruent. I also know that BD is congruent to CD because since this is the midpoint, it cuts that line segment in half. So BD is congruent to CD because AD is a median, and the definition of a median is that it goes through a midpoint. Then I need, right here in the middle, AD is congruent to itself. We call this the reflexive property. Anything is equal or congruent to itself. And then we finally have, what are we trying to do? Well, I could say that triangle BAD is congruent to triangle CAD because I finally have side, side, side congruency. That in triangle BAD, I have 1, 2, 3 ticks is congruent to triangle CAD with 1, 2, 3 ticks. So whenever I have given information, I'm going to make sure I note that on the figure. So side CD is congruent to side AB. That means this top side here is congruent to this bottom side. And CD is parallel to AB, so I'm going to draw these little arrows to indicate these sides are parallel to each other. Okay. I'm just going to start my proof with CD is congruent to AB, and that is given. CD is parallel to AB, that is also given. And then what else can I figure out here? Well, if I pay really close attention, if I think about parallel lines, I have this angle here and this angle here. So that's angle CDA and angle BAD. And these two angles are congruent based on the information. They are alternate interior angles inside of parallel lines. AIA is good enough. You don't have to write it all out. And then at the end here, this side here, the diagonal, AD is always congruent to itself based on that reflexive property. And now I have this side, this angle, and this side is congruent to this side, this angle, and this side. So I do have triangle CDA being congruent to triangle BAD based on side, angle, side congruency. So sometimes we don't have statements that are given us, we just have a diagram that's given us. Now we do have congruence in this diagram. You can see here this angle and this angle have a single arc, and this segment and this segment have a single tick mark. So I can go angle A is congruent to angle D. That is given. I could go BC is congruent to BE, that is also given to me. But then I could look even closer, and I gotta realize that this angle here, and this angle here are congruent because they are vertical angles. So that is angle ABE is congruent to angle CBD because they are vertical angles. And now I have triangle ABE is congruent to triangle DBC because I have an angle a side in this triangle, an angle on a side of this triangle. So what am I trying to prove? Triangle ABE is congruent to triangle DBC. Make sure you match them up because the tick was last. And that is because I have angle side congruency. Okay, those proofs are pretty short and quick. Seems like almost half the steps are given. This one's going to be a little bit more complicated. So I know that CE is perpendicular to BD. So I have this right here. I have a perpendicular situation. And CAB is congruent to angle CAD. So this angle here is congruent to this angle here. Okay, so I'm just going to start with my given. CE is perpendicular to BD. Given. And angle CAB is congruent to angle CAD. These are my two givens. Now we're going to get a little bit more complicated. So you guys really pay attention to what's going on here. That this angle here, these two angles added together, so I'm talking about this angle right here, being added to the original one. So I'm going to write this out and then say it. Okay, so those two angles are next to each other and form a linear pair. So angle CAB and plus the angle BAE equals 180, and the same goes on the other side. Angle CAD plus the angle DAE equals 180. They are linear pairs. Therefore, they're both equal to each other. From the previous state, well, we'll come to that in a second. So now I can say these two things are equal to each other. Because I have two sets of linear pairs that are, of angles, I can say they're equal to each other. So I have the statement down here, and that's just called substitution. Putting one thing equal to another. Going back to line 2, since angle CAB is congruent to angle CAD, that means their angle measures are equal. That means this angle and this angle, they're equal to each other. So I can get rid of them by saying the measure of angle BAE is equal to the measure of angle DAE, and that's just called subtraction. I just subtracted them out. So now I've established that angle BAE and angle DAE are congruent. Those are the ones that are in blue. I also have the idea that AE is congruent to itself. We already talked about this reflexive property. So AE right here. And then this angle right here, AED and AEB, they're both right angles. Angle BEA is congruent to DEA. because all right angles are congruent. And that finally leaves me with what I want. And I know I'm off the page here a little bit, but triangle A, be nice if I write it correctly. ABE is congruent to triangle ADE because I have blue arc, blue tick, right angle, blue arc, blue tick, right angle. So I have angle, side, angle congruency. Okay, so for this one, everything that I marked in red is given, and I put it into my little proof as given. Now I'm going to make some statements. And the idea is that how do I transition to get this triangle, KRM, which is a skinny triangle over here, is congruent to PRO, this skinny little triangle over here. Okay, going through this proof, 3 and 4 are a linear pair, 5 and 6 are a linear pair. That means angle 3 and 4 added together is equal to 5 and 6. But since 3 and 4 are congruent angles, and I subtract them out, that means 4 and 5 are congruent angles. So I have 5 and 6, or 4 and 5 are congruent angles. And then, by the angle addition postulate, I have this skinny angle plus this angle in the middle is equal to this red arc on the top, and this skinny angle plus this big angle in the middle is equal to this red arc on the right. But then, since this big angle is here in both of them, that means this skinny angle here, KRM, is congruent to this skinny angle here, PRO. So I have like 1, 2, 3, 4, and 1, 2, 3, 4. So I have these two skinny angles, and right now you can see, let me bring this picture up. I have angle, tick mark, angle is congruent to angle, tick mark, angle. So triangle KRM is congruent to triangle PRO by angle, side, angle. I know that's a little bit more difficult to see, and I wrote a lot of steps without talking about them. I will talk about them in class. And I talked about this the other day in class. This is a big idea, is that corresponding parts of congruent triangles are congruent. So all the 3 angles are congruent to the 3 other angles, and the 3 sides are congruent to the other 3 sides, matching the letters. This is very important in the idea of geometry and doing proofs. So the next one, we are given that a triangle is congruent, and we're trying to prove something else. So it says triangle PST, which is this one here on the bottom left, is congruent to the triangle RQT, which is this triangle on the upper right. Well, that means I have a lot of things going on here. So then it asks about PT and RT. Well, these parts are congruent to each other based on these triangles being congruent. So that's CP, CTC. And then it's asking about QT and ST. And they want to know why are QT and ST congruent? Well, since this triangle and this triangle are congruent, I again have congruent parts of corresponding parts of congruent triangles are congruent. Then it asks about this angle here. PTQ, which is this angle here, this angle is congruent to this angle here, RTS. And they're across from each other, so they are vertical angles. Now I can say that this triangle, RST, which is this bigger triangle on the lower right, is congruent to this triangle PQT, which is on the upper left, based on the idea that I have side, angle, side. I have a tick, an angle, a double tick, an angle, and a double tick, side, angle, side. And when I want to show that PQ is congruent to this bottom side RS, well, that's coming from this upper triangle here, this lower triangle here, CPCTC. Corresponding parts of congruent triangles are congruent. So this next proof is a little bit long, so I'm going to do it off camera. I'm going to write it all out, but I will explain it when I come back. Okay, of course I always start off with my givens, which are the three things here that this side and this side, IJ and FK are congruent, GH and JK are congruent, and HI and FG are congruent. And then I make the conjecture that GK, this long segment, is just adding up this little guy here and this little guy here. And that this guy, HJ, is GH plus this little guy here. Well, the one thing I know is that these were equal to each other. So I get rid of this JK, and then I have these two, this segment here is equal to this segment here. So I could say they are, so I have this segment here is now equal in length to this segment here. So they are congruent. 1, 2, 3, 4, 1, 2, 3, 4. And then so now I have this triangle is congruent to this triangle because I have side, side, side. 1, 2, 1, 3, 4 ticks, 1, 3, 4 ticks. And therefore, this angle here is congruent to this angle here by corresponding parts of congruent triangles are congruent. Okay, last page. J is the midpoint, right here in the middle of FH. That means these two guys are congruent because it's in the middle. And GI, that means these two are in the middle, are the same length, based on this and that. So let me just start off by saying J is the midpoint of FH and GI. Oops. That is just given to me. Step 2. HJ is congruent to FJ. And that is just definition of a midpoint. Well, guess what? I'm going to use that same idea again by saying IJ is congruent to GJ by my definition of a midpoint. But then I have this angle here and this angle here are congruent. So angle HJG is congruent to angle FJI because they are vertical angles. Please remember those vertical angles. So now I have tick, angle, double tick, tick, angle, double tick. So now I have triangle HJG is congruent to triangle FJI because I have side, angle, side. And then I can finally make the statement that this side FI is equivalent to this side GH because I know corresponding parts of congruent triangles are congruent. Okay, thank you for watching this video. Ask questions in class.